Hi, my name is Roger Palmer and I live in Victoria, British Columbia. My call sign is Victor Echo 7 Alpha Papa. This video documents a presentation to be given to the Island HF Radio Association in early 2024 entitled Amateur Radio. It's more than just a hobby. We all know that amateur radio means different things to different people. Depending on your interests, amateur radio can mean home brewing, contesting, working DX, experimenting with antennas, collecting awards, satellite communications, moon bounce, new digital communication modes, or just plain rag chewing. I'm going to talk about a different aspect of amateur radio, how it can influence careers, lead to the creation of new companies, and stimulate technology innovation. I'm going to illustrate these aspects by using myself as an example and talk about the synergistic relationships between these factors. The story starts in Dundas, Ontario in 1955. My parents gave me a kit to build a crystal radio using a cat's whisker detector. For those who haven't used these, the detector is electrically equivalent to a diode, but it is very fiddly and temperamental. After lots of fiddling, I was finally able to weakly hear the audio from a commercial AM station a few miles away. As a result of this project, I was hooked. I knew that my future would be in electronics, and I knew that I wanted to become an electronic engineer. But first, I wanted to get an amateur radio license. I sought out and devoured any publication having to do with the subject matter. Two primary sources of information were the Radio Amateur's Handbook by ARRL and QST magazine. My bedroom became my workshop, and I got into heavy-duty home brewing. In those days, you needed to be at least 15 years old to get a license in Canada, so I had to wait until 1962 before taking the test and becoming Victor Echo 3 Foxtrot Bravo November. Now I needed a rig, so I designed and built a 40-meter CW transmitter and planned on using my modified Heathkit AR3 communication receiver for receiving. I used a Heathkit RF signal generator as my VFO and used an 807 final that pumped out almost 50 watts of RF. It was difficult setting my transmitter receive frequency because the 40-meter band occupied only a sliver of the band spread on my signal generator or receiver. I also had a difficult time on 40-meter CW because of frequency setability, stability issues, and especially my marginal CW skills. Phone sounded like it would be much more fun, but it wasn't permitted on HF frequencies with my basic license, so I decided to try 2-meter AM. No one was using FM at the time. I acquired a surplus SCR 522 aircraft radio and set about modifying it using information from an old issue of QST. The rig used an 832 dual tetrode in the final, producing about 12 watts of RF using a push-pull configuration and plate modulation. Transmit frequency was set by an 8 megahertz crystal, feeding into a doubler and two triplers to get an overall multiplication ratio of 18. The receiver was an uncalibrated but continuously tuned superhet design, using a 6AK5 as the first RF amplifier. In those days, everyone operated split frequency. Determining your transmit frequency was difficult. I used a surplus crystal and fine-tuned the frequency using 600 grit sandpaper until I was fairly certain that I was in the legal 2-meter band. The exact frequency I wasn't sure of. I really enjoyed operating on phone. DX was about 25 miles. When I turned 16, I got my driver's license, so it was obvious that I now needed a mobile rig. It had to operate from 12 volts DC. I designed and built a reasonably compact rig that used a 2E26 final and a super regen receiver. Again, this is AM. The The 400 volt B+ supply was produced from 12 volts using a vibrator power supply. I knew that my transmit frequency was somewhere in the band, but I had no idea of its exact value. Frequency measurement was a recurring problem, and this motivated my initial career direction in future years. McMaster University was close to Dundas, so I entered their engineering school. Ham radio was put on pause because of the many useful diversions available. After graduation, I joined a Toronto-based company called Behringer Research. At Behringer, I was involved in the design of signal processing circuitry for correlation spectrometers, which are used for remotely measuring trace gas concentrations. I was mostly working on analog design with a small amount of digital. No more vacuum tubes. Everything was solid state, except for a photomultiplier tube. I picked up useful experience in synchronous detection techniques, as well as electro-optics. In 1969, I left Behringer and joined a small startup company called Carroll and Reed, who were developing an electronic distance measuring system for use by surveyors. This was basically a high-power CW optical radar, using a quarter-watt infrared light-emitting diode. We could measure out to almost 1 mile and claimed an accuracy of 1/8 inch. There were lots of analog, digital, and optical design challenges. The product displayed the measured distance using Nixie tubes. This was my first experience using this display technology, but I soon realized that these were ideally suited for other applications. I could use Nixie tubes and TTL logic, which was just becoming widely available, to create a frequency counter, just what a ham shack needs. I could finally get a handle on accurate frequency measurement. In a frequency counter, an input signal is converted into a square wave, and the number of cycles are actually counted over a known time period that is precisely determined by an accurate time base. The actual counting is performed by a series string of TTL decade counters. The outputs of the counters are latched at the end of the measurement period and then fed into drivers for the Nixie tubes. Thinking about ham radio applications, I designed and built a frequency counter at home, using the same components that we were using for the electronic distance measuring products. Meanwhile, the Carroll and Reed company was running into trouble. Capital was decreasing rapidly, there were production startup problems, the economy was faltering, and the investors were getting nervous. Payroll was missed for several weeks. This sounded like the perfect time to start a new business. Another ex-employee and myself formed a company called Analog Digital Research, based in my apartment in Toronto. Our initial business was to manufacture and sell frequency counters based on the design I had developed for my ham radio needs. Here is a photo of the very first product. And here is an actual unit. Okay. This was purchased by the University of Waterloo in about 1971. It is well over 50 years old, has many scratches, the controls stick and the connectors are tarnished, but it still works. At our company, sales grew exponentially, but we experienced the usual growing pains. We moved twice into larger premises, and working capital was always a problem. In order to maintain our competitive advantage, we next wanted to develop a custom MOS, metal oxide semiconductor, integrated circuit that would implement the bulk of the counter's logic functions into a single device. We needed a major capital injection to grow to the next level. We'd exhausted our traditional borrowing options, and conditions were not good for bringing in more outside investors. So, we sold the entire company to Fluke in Seattle. I moved to Edmonds, Washington at the end of 1975 and headed up engineering activities in the newly formed Frequency Measurement Division. We repackaged some of the existing ADR designs to look like Fluke products and developed several more products in the lineup. There were several other hands at Fluke, and they all kindled my interest in the hobby again. The landscape had changed completely since the 1960s, and all kinds of commercial gear was available. 2-meter FM gear was everywhere, and repeaters were commonplace. We even had a 2-meter repeater at Fluke, equipped with an auto patch. I installed a Japanese synthesized FM rig in my car, together with a DTMF touchtone pad for making auto patch calls. Meanwhile, Intel had started producing the 8008 microprocessor. The world was about to change, and several of us at Fluke got involved in home computing. Most of us standardized on the S100 bus, as it was becoming widely adopted. I developed several S100 board designs for my own use, and then sold the designs to IMSI. Working at Fluke was fun and very educational, but I was now a small fish in a bigger pond, so I started to look around at other opportunities and joined another startup company. In 1978, I joined Intermec in Mukilteo, Washington, as their engineering manager. They were a small, vertically integrated company developing printers and scanners for barcode. We operated out of a modest steel building in an industrial park. As the business grew, we took over more and more of the buildings in the park. At Intermec, every product had a microprocessor. Our develops encompassed a wide variety of fields, including optics, mechanics, circuit design, networking, pattern recognition, information theory, and software. The company grew rapidly, and I grew with them. We left the industrial plaza and built a new modern headquarters building near the Boeing plant in Everett. There were several hands on the staff at Intermec. Several of us were also involved in homebrew computing, developing both hardware and software. I stayed at Intermec for 16 years, the longest I've ever held down a job. Starting when I got married in 1970 in Toronto, I'd always had a boat and was actively involved in sailboat racing. When we moved to Seattle in 1975, I bought a bigger boat and got involved in the local racing scene. I installed 2-meter equipment on board so I could make auto patch calls. When I joined Intermec in 1978, I bought a new CNC 36. I equipped it with 2 meters and an Atlas 210X high-frequency rig. Some of you might remember the Atlas 210X. It was a non-synthesized solid-state sideband rig putting out 100 watts. I used a Hustler vertical and saltwater ground. I entered the 1978 and 1980 Victoria de Maui races using the Atlas 210X to keep in touch with family and friends back on shore. In 1981, I acquired a Baltic 42, which is built in Finland. I equipped it with an ICOM IC701 HF radio and raced it to Maui in 1984 and 86. The IC701 is one of the first synthesized HF radios. I initially used a Hustler mobile antenna, but then progressed to using the backstay, using an ICOM AH2 automatic tuner. At about the same time, I got a US extra class license and became known as Alpha Alpha 7 Alpha Bravo. I eventually burned out from sailboat racing, and in 1990 we decided to switch from sail to power. In 1991 we found an old steel trawler in need of a lot of attention and started an extensive 18-month rebuilding project in Seattle's Lake Union. We finished the project in 1994, and I retired from Intermec and moved to Victoria with the boat. I then became VE7 Alpha Papa. We enjoyed cruising in the rebuilt trawler. I installed an ICOM IC735 HF rig and used an AH2 automatic tuner to drive an inverted L between the two masts. The steel hull in salt water is an ideal ground. It also acts as a perfect Faraday shield. There was absolutely no noise or interference from any of the systems on the boat. As part of our West Coast cruising, I made a habit of checking into two 75-meter boater's nets. I could always hear them because of my low noise level, but they sometimes couldn't hear me because I was only running 100 watts. As we cruised further and further north, this non-reciprocal receive noise issue became more of a problem, and it was obvious I needed to put out a bigger signal. I needed more power. I discovered that Henry Radio had a 1200 watt solid-state HF linear amplifier that could operate directly from the boat's 24 volt battery system. Now I had to find an automatic tuner that could handle the power. I acquired a surplus Harris RF601 automatic tuner that could easily handle the power levels. It used two servo motors to drive a vacuum variable capacitor and a roller inductor. However, the control unit was very large and wouldn't fit in the space available. The control unit did not use a microprocessor and performed its function using traditional analog techniques. I decided to design and build a modern controller using a microprocessor and let the software do the heavy lifting. The controller interfaced with the IC735, the amplifier, and the tuner unit itself, which was mounted on the top deck, directly below the inverted L antenna and grounded to the steel deck. Here's the control schematic. The heart of the design is the PIC 16C74A microprocessor, which includes an A to D converter. The amplifier was located next to the batteries to minimize cable losses from the 100 amp peak current draw. The controller was located right next to the IC735 in the operating position. The extra power certainly helped. I found that I was able to check into the 75-meter nets from anywhere on the west coast of the continent.
A little bit of rain around 1800 or around 1700, but no heavy downpour yet, and all is well.
Time doesn't stand still. After our children grew up and moved out, we no longer needed such a large boat. I also discovered that steel boats require a lot of ongoing maintenance, and I was ready for a break. So in 2007, we downsized by 10 feet to a new Celine 47, which is a fiberglass trawler built in mainland China. I equipped it with an ICOM IC706, which is an all-band, all-mode 100-watt transceiver. There's a 23-watt vertical fed by an SGC automatic tuner. Getting a decent RF ground was problematic. I ended up using the stainless steel railing that runs around the deck as a counterpoise, augmented by a connection to the underwater fittings. A fiberglass hull does not work as a Faraday cage. I had major problems with RF noise caused by all the digital switching circuitry and motors on board. I also found that my transmitted RF was getting into and affecting the LED lights, the stabilizers, thrusters, water maker, and propane sensor. I managed to finally get the RF susceptibility under control by using numerous chokes, bypass capacitors, and localized copper sheet shielding. Having only 100 watts and dealing with a high receive noise level somewhat limited my abilities on 75 meters, although higher frequencies were a bit more usable. In 2018, age and health issues prompted another 10-foot downsizing. We bought a Batco 37 and didn't permanently install any hand gear. When we go away in the boat, I bring along my new ICOM IC705 and use an extendable vertical antenna temporarily mounted on a railing. I use the same radio at my minimalist home QTH, which is an Oak Bay condo. I now operate almost exclusively on the new digital modes, as I find that 10 watts is all that is needed, and the noise environment is easily handled. My antenna now is a 23-foot random wire on the roof of the condo building, fed by an AH705 tuner, and using the building's sprinkler system as a ground. Since I first got my amateur radio license, technology has evolved radically. We went from vacuum tubes to transistors to TTL to ECL and then to large-scale MOS integration. Traditional analog circuitry has evolved to digital solutions. Dedicated circuitry and systems have been replaced with programmable microprocessors. There's been a progression to higher frequencies, faster clock speeds, and unimaginable complexity. Amateur radio has embraced and/or driven this evolution. Amateur radio influenced my chosen career path and continuously pushed me forward. And it all started with a cat's whisker crystal radio about 70 years ago. Amateur radio, it's more than just a hobby. I was involved in several other ventures that I did not include in this presentation because there was minimal amateur radio content. If you are interested, much of this is outlined on my website at www.paltech.ca. Thanks, and 73.